All right, so we were talking about Le Chatelier's principle, and we were talking about stressors, what changes I can make to the system so that it messes up my equilibrium, and how is it going to shift. All right, so the last thing we have to talk about is temperature, and then we have to talk about catalysts. So sorry, two things, temperature and catalysts. Okay? And then we'll actually have covered everything in this table. So this table is kind of a good summary table if you want to look at it. So we're going to talk about temperature and we're going to talk about catalysts, and that's it. We'll be done with chapter 15. So today's lectures are going to be really short today. So you can take time to work on your quiz, work on your homework, kind of get caught up and start studying and get ready for your test on Monday. So less quizzes and you can work on other stuff. All right, so let's knock out the last couple of slides. So let's talk about changing in temperature. So if there's a change in temperature, it changes Kc. Remember we said that the K number, this value, is temperature dependent. Okay, so the K, the actual number itself is temperature dependent. Now, the Kc, this number, may increase or decrease if temperature is increased. Well, you might say, wait, here temperature is increasing and my K is getting bigger. Okay, so here Kc increases as temperature increases. But you just said up here it may or may not, depending. What we have to look at is something specific for the reaction. We actually have to look to see, is the reaction endothermic or exothermic? Now, we have to look at the enthalpy. This tells me what's going to happen. Okay? It's a little bit more detailed than just saying, oh, if temperature increases, K always does this or does this. It depends on if it's an endothermic or exothermic reaction. Okay? And I get that from the enthalpy of the reaction. Okay, so let's look. Remember here, this number, if it's positive, it's endothermic. If it's negative, it's exothermic. Okay, so you got to look at it from that way. All right, so what I want you to do whenever you have a reaction like this, and I'm asking you about the temperature, what I want you to do is figure out, is it endothermic or exothermic? So in this case, it's endothermic. So if it's endothermic, it means it needs heat. So heat would be a reactant. So I want you to write heat on that side. Say this were negative 180. It's exothermic, which means it releases heat. So heat would be on this side. So I want you to write heat wherever it would go based on the H. So in this case, it's endothermic, so we write heat here. Then I want you to just think about it just like if we were to change the concentration of one of these guys. Just think about it that way. Okay, so heat's on that side, and we said we increased the heat. So this guy, he's going to go up. What did we say at the very beginning when we did concentrations? We said if I add, I shift away. If I remove, I shift towards. So if I increase heat, I shift away. If I decrease heat, I shift towards. But I have to know where heat is. That's the extra part. Is it a reactant or a product? Okay, so it's endothermic. I figured out it's a reactant. I increased the heat. Okay, so it needs to shift away. Okay, so it's going to shift away. So it's going to shift towards my product, so it shifts forward because this forward reaction is endothermic. Okay? So heat's here, forward reaction is endothermic. If I increase this, shifts away. All right, let's talk about if I reduce it. Okay, so if the temperature is reduced, so this goes down, I need to shift towards it because I want to increase the heat. Okay, so I'm going to shift towards it, so the equilibrium is going to shift in reverse. Okay, if it shifts in reverse, it's doing the opposite of what this is. So if this is endothermic, the reverse reaction is exothermic. So what I want you to do is just think about where heat goes, is it a reactant or a product based on this guy, and then add or subtract it like we did if it were just a reactant concentration. Let's summarize. Exothermic reactions. The number of the Kc will decrease as temperature increases. So the Kc number decreases. So let's think about this. Kc is products over reactants. If it's exothermic, I got A plus B goes to C plus D. If it's exothermic, then I'm releasing heat, so heat is here. If I increase the temperature, I shift away, I make more reactants. I make more of this bottom number. This bottom number goes up. So if this bottom number goes up, my Kc goes down. Okay? Because exothermic, they are less product favored. They are reactant favored. And it's just kind of summarizing everything we've talked about. All right, let's do endothermic. Endothermic reactions. A plus B goes to C plus D. If it's endothermic, I need heat, so heat would be like a reactant. Kc is products over reactants. All right, I increase the temperature. This goes up. So I'm going to shift away. So I'm going to make more products. So I'm going to be, these reactions are more product favored. I'm going to make more products. So if this goes up, this goes up. That's why my Kc increases. Okay? So it all ties together. So if you're talking about temperature and how does temperature affect a reaction, you do not know the answer to that unless you know if the reaction is endothermic or exothermic. So if you don't know if it's endothermic or exothermic, you have no idea what's going to happen if you increase or decrease the temperature. So you have to know if it's endothermic or exothermic, and that comes from the sign of this guy. Positive endothermic, negative exothermic. Okay? All right, last thing. Let's talk about catalysts. So what do I do if it's a catalyst? So let's first talk about what catalysts do. So if I dump in a catalyst, it speeds up my reaction. It speeds up the forward. Because remember, if this were my uncatalyzed reaction, then my catalyzed reaction starts at the same place, ends at the same place, but my hill is just shorter. So the forward reaction, going from left to right, is faster because my hill is shorter. But at the same time, my reverse reaction, instead of going over this hill, it's shorter also. So also the reverse is sped up. So it speeds up the forward, speeds up the reverse. What it does is it decreases the time needed to reach the equilibrium. But does it change my concentrations at all? So think about this. I can change, the things I can affect are concentration, pressure, volume, and temp. That's everything we talked about. So we could go all the way back to the front table and see everything we talked about. We said concentration, increase or decrease, pressure, or volume, temperature, and a catalyst. Okay? That's the only things I can do. Nothing else is going to change it. So if I add a catalyst, I don't change the temperature. Add a catalyst, I don't change the volume. I don't change the pressure, and I don't change the concentration, because remember, a catalyst doesn't affect the reaction at all. Okay, so review this from the end of our rate reaction. A catalyst is not a reactant, not a product. It's there at the beginning, it's there at the end, it doesn't react. So catalysts do not affect equilibrium concentrations. So if I ask, a catalyst is added, which way is the reaction going to go? You would say no change. Because catalysts do not affect the direction of my equilibrium. Doesn't affect it at all. All right, so that's it. Everybody's doing a great job. You're working hard. So you've got Chapter 15 quiz. You got the rest of your Chapter 15 homework coming up. So check my awesome essay for those topics under there for the deadlines for everything. And Monday, you're gonna have your first test. All right? Remember, I have my live office hours. Some people have been coming. I've been posting on right underneath where the Google Doc is if the office hours change from the normal office hours, but you can come to the live office hours. If you can't make it to the live office hours, then post questions in the office hour document, and then whenever I come back, I'll check it and I'll leave you an answer, okay? But come to them. I've had several people come to live office hours. So I've been told to give a shout out to everybody that's been working hard. So for example, people that have been working hard. So Ashley Zayden, she's been coming. Caleb Brown's been coming. Maddie Gray's been coming. So I've had several people come to office hours, and it's been really beneficial because you get a lot of help. Also, don't forget, I've been posting, as people ask me questions about the homework, I'm posting my responses in the homework doc. So if you go to the Chapter 15 topic and you look at the top, there's the answer key there. Use that to help you, but don't just copy the answers down. You gotta know how to do this for the test on Monday, okay? So make sure you're practicing it. If there's not an answer in there, that means you gotta ask me. So ask me the question in office hours, and then we'll work through it, and then you've opened up that question for everybody else in the answer key, all right? So don't wait till the last minute to work on your homework, to ask me questions, to get adjusted to all this. I know it takes time, but you guys can do it, okay? So get ready. First test is on Monday. Good luck, everybody.